So in this video, I'm going to discuss the "We Were Both Children" problem which occurred in today's Forces challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I'll pin them. So the problem statement is very simple. It is given that you're given an array which is the number of jumps, sorry, the length of jump that a frog can do, and this is the size of that array. And what you can do is you can put a trap at any position from 1 to n. Okay, remember you can't put it on 0. So from 1 to n, at any position you can put the trap, and the frog starts jumping from 0. So let's say for the first frog it starts jumping from 0, then it goes to 1, then it goes to 2, then it goes to 3 and 4 and 5, because it is incrementing by 1. The second frog can start from 0, it goes to 2, then 2 plus 2 4, then 4 plus 2 6, and so on. Third frog will grow from 0 to 3 to 6 to 9, because that is the difference. Okay, so what you have to do is you have to find out, like if you're putting a trap at any position, you have to find out how many frogs are going to be caught at that position. Okay, so for this case, if I put a trap at, let's say, position 4, then the frog at 0, the first frog, it goes from 0 1 2 3 4, so it steps at 4 and it gets trapped. This second frog, it goes from 0 to 4 and it gets trapped, right? The third frog, it goes from 0 3 6, it has crossed the trap. But the fourth frog, it goes from 0 to 4 and it gets trapped. And the fifth frog, obviously it is going from 0 to 5. So how many frogs we can trap maximum? That is 3 frogs. Okay, so the best, so now you, this much is very much clear, that you have to find a number which will be having the factors. Okay, these are basically factors. So let's say if we are considering 4, so 1 2 and 4 are the factors. Okay, so you have to consider a number which has the maximum number of factors in the array. So what you can do is, basically the constants were given as n is of the order 10 to the power 5. So this basically means that we know that 10 to the power 9 is the limit, right? So n squared is not possible. But remember one thing, n square root of n is possible, right? So first of all, you can take a map and store the frequency of all the elements in the array. Okay, so step 1 will be frequency store in map. Okay, so once you're done with the frequency storing, so then at the next step you can do what, you can check for you can run a loop. So for all the elements, that is from 0 to n minus 1, that is for all the elements of the array, you have to check, sorry, I made a mistake, sorry, not for all the elements. Okay, so from 1 to n you have to check that which, so from 1 to n you have to put the trap and check how many frogs are going to be caught at that position. How you are going to check? You can like check all the divisors of this. So let's say this loop is ith loop and this loop is the jth loop. So for all the factors of I, okay, so for all the factors of I, you can check if that element is present or not, and if it is present, so answer will be the frequency of that element. Okay, that is answer plus frequency of that element. Okay, so like I know this is getting complex, so let me do one thing. I will be explaining this one. Okay, a perfect example. So for 3 1 3 4 9 10, so the map looks like 1 3 4 9 10. 1 is present 1 time, 3 is present 2 times, 4 is present 1 time, 9 is 1 time, 10 is 1 time, right? Very much clear. Now you have to run a loop from 1 to 6, right? From 1 to 6. Now remember one thing, for checking the factors you can do it in square root or n. Okay, I don't think I need to explain that thing. Okay, so you have to find out the factors of 1. How many factors of 1 are there? Only one factor of 1 is there, that is 1. So what is the frequency of 1? It is 1. So initially let's say that the answer was 0. Now the answer will be maximum of 0 and 1, that is 1. Now we have to check, so for 1 to 6, so let me write it like this. So 1 is done, right? Now we are going to check for 2. 2 has two factors, 1 and 2. So 1 is here, 2 is not there. So that is again 1. So answer is also 1. Now for 3, it is 1 and 3, right? That is this and this. So what is the frequency of both? That is 2 plus 1, that is 3. So now this gets overwritten as 3. Okay. Now we are going to check for 4. For 4, it is 1, 2 and 4. So 2 is not here, 1 is here and 4 is here. So 1 plus 1, that is 2. So will we overwrite 3 as 2? No, because 3 is the maximum till now, right? And we have to find the maximum, so we don't overwrite this. Now for 5, it is 1 and 5. Okay, so it is 1 and 5. 1 is here, 5 is not there. So 1, we don't overwrite it. And for 6, it is 1 and 6. 1 is here, 6 is not here. So we don't overwrite it. So the answer is 3. So the answer is 3. So that's how you need to do this. This is a little bit like very interesting problem. So that's it from my side. Thank you.